Thanks for the nice introduction, Dr. Kwan. My name is Kyu-Sang Lee, as I introduced. I would like to tell you about how to choose what to do based on mostly based on my personal experiences. So I will start by introducing myself. Okay, if I can operate this. Okay, so I got my BS degree from postdoc in 1992 and immediately went to the US for my PhD in material science and engineering department in the University of Illinois at Urbana-Champaign. By the time I finished my PhD, because I have not finished my military service, I was searching for a job in Korea, and I joined Samsung Electronics at the time into a Samsung Advanced Institute of Technology and worked there for immense amount of years, for 16 years. And I ended up working on bio area while I was doing my military service in Samsung, and continued to work on that field for more than 13 years during my career in Samsung. And after I left Samsung, I joined a company called Clinomix. Some of you might have heard of it, this company. It's a company founded by a few colleagues of mine, as well as Professor Chung-Hwa Park in the same department, and did IPO in the last year. And I was CTO there and worked as a engineer and also developer. And after that, I joined UNIST as a research professor and worked here. I'm still working here, and I have also a position as a CTO at LabSpinner since April, and I'm planning to, and almost starting my career, second career as in the venture industry as a CEO very soon. So I'd like to tell you more about my story or my view into the bioventure and how to, develop a new technology that are being introduced to the market. Okay, the next page. So these are the major list of projects that I did in the genetic diagnostics area since I started working in Samsung. And the last title is like a head of liquid biopsy research institute in Clinomix. And I worked on developing fully integrated lab on a disk platform for liquid biopsy for cancer diagnosis. Some of you might have heard a few keywords in here, but I believe most of you might think that it's kind of a magic box that does something that you may not be interested at all. But by looking at a few words in here, maybe you could look them up in the webpage, in their internet. These are pretty interesting technologies. And I would like to tell you how I ended up working on this based on the other projects and experiences I've done. I have had within Samsung and as well as outside of it. So I'll briefly jump to the next slide, which might be a little bit interesting. So in the first line, I told you that I studied material science. Why did I go there? Because it's Iron Age, right? Is it still Iron Age? Somebody says it's Information Age. But after I joined my material science department as a freshman, everybody in the department was saying that, okay, iron rules, Still is like it's a better version of iron, but it's still Iron Age. And okay, maybe that's true. And after I've worked there, studied there, basically the college and the academia has been going through very serious changes over time. Over the last 20 years or so, it seems everybody's working on, everybody in the academia seem to have increased interest in the biotech area. So you can easily find someone who did some kind of engineering in biotech area very easily. And but at the time in my freshman year, I didn't really look that much wide or deep into other area than my own, major. So if I tell you why I had to do that with this very simple graph, you can see that the iron or steel production of my age when I went to college, which was 1988, was somewhere in here. At the time, Korea was somewhere in between. It's labeled as rest of Asia, and Korea was somewhere in here, and Japan was the largest steel production country at the time. We didn't realize China was coming up in the next 30 years or so, and Korea was always thinking about, especially because I was in post-tech, POSCO at the time was interested in Japan as the huge competitor, and they were the bad guys, and we were trying to beat them. And by beating them, we kind of thought that, okay, we'll be the #1 in the world and we'll rule the Iron Age. Very naive idea, right? But when we look at the steel production these days in here in 2020, okay, China is #1 by a very huge margin. And by looking at the individual companies, India has emerged as #2, which was very odd. If you imagine what was it like, what it was like in 1988, and that is because India has acquired several huge steel making companies afterwards. So it is kind of meaningless, I believe, that for a freshman to predict like 20 or 30 years later, because everybody else don't have that type of a prophecy-like power to predict what's going to happen. So so that's about it, about my material science story. And my title says, how to choose what to do. So people will usually think that, what am I good at? People said, oh, you draw very well, so you better be a painter. But it can be something that I don't like. So there's a question of what to do when we look at what I am good at or what I want to do. And there's also one thing very important, is that what my environment is like. Basically, for students, it's mommy. What your mom says is mostly what you want to be. Which country, which college you to go, or whatever you want to do. So it's kind of odd, but usually mothers don't really have that much information compared to other people outside in the society. So that is not a very good environment, I guess. But when we look at it in a more, say, over time, from my experiences, it's the age of technology. Oddly enough, the society is made of different type of structures based on, say, customs, and also, say, different occupations and politics and such. But when we try to focus on our environment, it is very sure that it's the age of technology. And it's usually the word used by elites who have achieved something in the academia, or especially in the technology or science area. And they usually find some business opportunities based on patents. And that gives you some legal protection of your business, and that becomes your power. And it also works as the entry barrier for others who are competing against you. So it is pretty obvious that, because you are also good at it, environment and your ability usually makes you think that you can do something with the technology. Something else one can think about is resources. What do I have? If I have something, if I'm good at something very well, some very specific areas, then you can make good use of those resources in order to achieve something, or you can learn something, or you can work on start business and achieve some goals. It's mostly based on trust, by the way, because we don't really know what's going to happen, but based on those resources and the those capabilities, you can achieve something. And these 2 points are something that you start, and when you're looking around your starting point, you usually think about something you can easily start with. But by the time when you are working to achieve some goals, you have to always think about the customers. Customer is a very vague word, but it's a very significant in a sense, because you are delivering something. Because when you do some research, and people will somehow evaluate you and how good you are, and they will also decide if it's worthwhile to give you some research fund based on your research performances. And those research results have to be presented somehow in the form of some product to your customers. Customers usually evaluate you and they give you additional resources. So we have to think about it again. Maybe we need to think about the customer first and then collect resources and make use of technologies that are available. So it is something something odd, because you said you originally thought that, okay, I'm good at something, say technology, and I have some resources, my good friends, and my grandfather who's very rich, he's got a lot of money, so I'll sum them up and maybe you can start a business, or our country is very rich, so they can give you some research funding and then you can achieve some great scientific achievements. But in many cases, customers, those evaluators, usually think or they decide what is going to happen. So it is very important to think about the customers first, although you may not like it. So that's what has been, what I have been observing throughout the careers, I would say. So first observation, customers. Yeah, they're people. So we know that we have seen many of these demographics, the infographics, sometime in our lifetime, saying that, okay, not just the geographical pictures, but there are a lot of people in the world, say China, India, the big giants, and also other countries. We have to look at the people and also how they live and what they like or what is necessary and how I can improve their life or influence them. We need to know about people. So first thing is looking at how many people there are in which part of the world. Maybe we can just do this within our country or within our college or within our family as well. But when you look at the population, there are, a lot of people. But by just looking at the number of people, that doesn't really give you good information. So what people usually do is doing demography. It's a way of customer segmentation, because the population is a mixture of different people. One has to understand them, and they have to be categorized to some similar groups. And usually products or research results or whatever you supply them as a presenting material, you have to select some of the groups which may like your product or presentation. So easiest way is looking at the age. Okay, old people, if I sing some very old generation song, they may like it. If I dance like that, they may like it. But if I play with some BTS or whatever you guys are very familiar with, they may not know what you are trying to do, and may not be interested at all. That is very true in every single generations, and that's why people have been saying MZ generation, or in my case, X generation, whatever generation they have to name them. And they are basically the way of doing customer investigation, customer segmentation, and also a very good marketing tool, because you are homogenizing those within those segments, and you are trying to appeal them with something that you have. So it is the first approach that you do customer segmentation. But basically, you don't really know customers until you segment them, because the only information you know is that they are human and they are alive. But each segmentations have different needs, trend, culture, income, economic performances, or health conditions, and basically different needs. So you have to understand them. Okay, so you looked at the age, so let's look into the age more. This is another information that is available on the internet, how people are doing with their lifespan. And you can easily guess that, okay, we are improving, we are living longer. You know that information. Also, we have many more older people, older generation than before. Say some grandpa would say that, well, when I was at your age, blah, 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 blah. Well, yeah, at that time, there were not that many old people. That is very true. Now, there are a lot of old people. Very huge population is, they are old. And interestingly, they are also they have they're rich. Mostly they've collected throughout their whole life with their money. So they are richer than younger generation. And if you look at this, you can find South Korea here in the 1800. Only the average lifespan is something like 25. It's unbelievable. But you know that many kings have lived like the age of 60, 70, or 80. And you know that if you look at people who live very long. So what do you think is happening in here? Why do we live only up to 25? Why do the average age becomes like this? Can anybody give me some insight? I know that you don't get any higher score by answering this, but it's very easy. Many people have lived here only to the age of 1 or less, and that reduced the average age significantly. So the reason why people was not able to live longer than this on average is because there were a huge amount of dying kids, very old, very young children. They ended up losing their lives in the very early stage of their lives. That is still very much true in many of these countries even now. And South Korea has evolved from this stage to this and that very rapidly. And the main reason is because we were able to reduce the child healthcare, child health risks. And not only that, globally, the average has increased quite a bit by the improvement of personal hygiene and discovery of antibiotics or drugs in the form of different types of medicines. When you look at the child mortality, now the reason why I'm telling you about this is because we want to know about our customers. If you look at the child mortality, there were statistics that says that, okay, over the years, children under the age of 5 are dying, but they're decreasing. Okay, good thing. People are surviving better. And maybe one of those reasons is because babies are not born, not too many babies are born. So people can, give the babies better care, and mother can, stay healthier to support them. Maybe that's one of the reasons why the childbirth, the child mortality has increased quite a bit. So that is one of the reasons. So those are the some of the possibilities that you can find some needs related to ages, but it's some example that's not related to say commercial success, I would say, because many of these countries don't really have capability to buy your ideas, or they cannot afford them. But many of the developed countries already have approached here. Then they are almost here. So as we are living in somewhere up here, along with many of these developed countries or developing countries, we need to look into more of these guys. There's another very interesting curve. This is also something you can easily find from the internet. Yeah, it's a very interesting curve. And in here, it says this. So I'll try to explain this. This is a very interesting curve. In 1950, say, in 1950, the age of the life expectancy of 70-year-old grandpa or grandma was 79. They can live 9 years more. By the year 1950, they can live a bit longer. Wow. So nowadays, they live a lot longer. Oh, that's good. So even very old age people, they can live longer. 60-year-old people, similar trend. Everything is similar. Aha. So it's not that difficult, curve to understand. When you look at these the gaps between these curves, it tells you that a lot of people are dying, by failing to fill this gap. But if you can survive long enough, 10 years, then you can jump up to this curve and you can expect, longer lifespan. If you live 10 years longer, you can jump up to this curve and expect higher lifespan. It goes like that. But something very interesting has happened when we looked at this curve. This is that huge drop. So what does it mean? If you are 1 year old in early 1900, 1920 or 30 or so, you can expect to live about this age. But if you're born around here and you're only about 1 year old, you have very low life expectancy, which means that a lot of people are dying. But interestingly, these people, they don't suffer that, tragedy. Well, they don't really die off. What's happening? Can anybody guess what was the main reason in here? See, they're all Superman, super old men. They don't die away. They survive. They can fight against this some type of tragedy that kills younger generations for some reason. No? Yeah. I'll give you the answer. Oh, sorry. Just a sec. Why doesn't this go away? It tells you Spanish flu in 1918. Spanish flu broke right here, and many young people died. But if you look at these days, older generations were hit much severer in COVID-19. But why did younger people die so many, and not for the older generation? That is because of this event around here. It's a Russian flu that occurred during the late 19th century. Those who survived this Russian flu, they were immune to this Spanish flu. So they were able to live very successful life, and this is the reason why you have to get vaccinated. And they didn't have that, natural vaccination event, and they suffered quite a bit when the Spanish flu hit you. By looking at this, okay, yeah, and then there were some more similar events in here in early, like Asian flu or some other things in here as well. But even then, younger generations were hit, and we were not prepared with some vaccines. And when we looked at this, we were rather thinking that, okay, I want to be like the Superman. Can anybody have all different kinds of vaccines against infectious diseases? And also possibly cancer that hit this, older generation people. If we have those tools available, then this curve might go, way up high. And it has been a similar trend that's driving us, up here when we look at the age. So much for the flus. And there has been many observations like this. So people have been trying to save lives by developing vaccines. As I told you, the Spanish flu killed about 40 to 50 million people. AIDS is also killed quite a bit, but also the one that I just mentioned you, the Asian flu or Hong Kong flu, they also killed millions of people. Ebola, that was rather small. And now COVID-19 emerged. It was about 1.7 million deaths last year, sometime in the October. Now it's over 4 million people who died because of this. So the bubble is growing bigger and bigger. And people were, at this time, the environment was squeezing all different technologies and resources available to save people against coronavirus. And it took, record time in developing the vaccines against this disease. It was just unbelievably, fast reaction by human race this time that hit against the coronavirus, the other the infectious diseases. And if you talk about the Corona-19 a bit more, this is a news from Singapore. I got this about 2 weeks ago. Ong Ye Kung, the Minister of Public Health in Singapore, now says that we are going to live with Corona-19. And this is how we're going to do it. By vaccinating, fully vaccinating, not many people are going to die. We are making that dip into a very flat line. This is all based on those scientific observations and our fight against it. And we are successfully making moves to it. And surely Korea will join Singapore's path pretty soon, I think. So by looking at this statistics and event, people were making reactions very quickly in order to solve our problems, and there were needs by our customers, especially related to the lives. But people are still dying, because living things die sometime in the life in their lifespan anyway. So many people are dying, and there are some statistics that people have been collecting how they are dying. If you think about how they're dying, many of them are dying because of cardiovascular disease. Your heart fails, or your blood vessel breaks up, and you end up dying. And cancer is another very huge disease that kills us. Respiratory disease. This one is they mentioned communicable disease, and this is non-communicable disease. And communicable is like some infections. And these are, the blue ones are not some, external element that tries to kill you, but the red ones are basically the infections that are trying to kill you. So the blue ones are more like related to our basic biology, genetics, or our way of life, and the amount of exercise that you do to make you healthy or ill. But many of these in here, COVID-19, as you all know, have emerged very suddenly, and then is still growing in the very much portion of unvaccinated people. And because of this, people have been working on saving lives quite a bit. And my personal choice of working in the biotech field also started by looking at these. Where are the needs of our customers, and how we can help them by making use of the technology that we have access to. So after doing all these observations, how are we going to approach what to do and how to do? When I was in Samsung, working with the consulting companies, trying to come up with some very large statement, we were forced to make these 4 points. The first one is needs. What do our customers need? How can we find it? We should go out and ask. This is basically the easiest and most accurate way. You have to ask them and get the information. Not only customers, but also collaborators, my teachers, my kids, my friends, everybody. Very important. After knowing the needs, we have to come up with some approach. Something different or maybe similar, but in a way we can do better. Yeah, we have to find the approach. And also we have to present this to the customer somehow so that we can fill their needs with some benefits that we are applying. So benefits have to be clearly stated, but they are benefits for customers, not you. It's not like it's very profitable, so it'll be a great benefit for me. So, well, yeah, that's good, but it's not for the customers, so customers may not like it. One of the big example is this: in the 80s or 90s, new tomatoes were developed by Monsanto. The tomatoes get easily smashed during the transportation, so they developed a tomato that doesn't mush, over time. Like it just looks freshy over the weeks. So Monsanto thought it's a very good benefit for customers, but customers never thought so. Okay, we don't really know how old that tomato is, so customers didn't really like it. So the benefits have to be some benefits for customers, not us. And also we have to know about the competitors. So when we think about something, what to do and how to do, we need to come up with many of these 4 points. Then we'll be able to communicate much better. So we are asking. When looking at the life cycle, yeah, after birth, it seems you're healthy, but we go back and forth the diseased and healthy conditions over time. And in the disease state, the red circle that we saw before, that's infection. For the other things, the blue ones, they have some genetic backgrounds that are influencing our health condition. So we can come up with these two, and also some injuries that are occurring from accidents. And after looking at this in my personal experiences, we wanted to work on these two areas, especially making use of some technology that uses a genetic approach. And one of the biggest market we thought about was cancer. We looked at the statistics, how people are dying, and cancer is one of the largest therapeutic markets still. And they are very interesting, approach at the time, like early 2000 approach that were emerging, which is now a standard way of treatments and diagnostics in cancer. And people have been working on it very much. And there were many different unique ways of approaching them. So I worked on them. And when you look at the statistics in UK, there are two messages. Okay, there are 4 largest cancer groups that are life-threatening in UK. And if you look at them, if you can diagnose them early, many more people can survive compared to being found in later stage. And also it costs much, much less. Rectal cancer or ovarian cancer, they are the same story. Lung cancer, slightly different one, but it still, gives you a better answer. Lung cancer has been also a big problem within this in here. And in here, if you look at the year, it's year 2014. The lung cancer has now many more different news. It's many more people are surviving, and that is because something, our generation of people have worked on the therapeutics as well as diagnostics. But big message is that early diagnosis saves lives, and that helps. And more targeted approach of therapeutics also saves lives, and that are making changes. So if you look at the diagnosis first, how do we diagnose? Imaging, or before imaging, we were doing like looking at the face, measuring the temperature, or asking, or you can touch, the doctors can touch the patients and find out where the ill portion of the disease portion of body is. And they worked on, different kinds of treatments. But from the technology point of view, major diagnosis methods are imaging or the newly arising molecular diagnostics. It's not new anymore, but the molecular diagnostics is a big branch of the diagnosis. I'm not very much of an expert of the diagnosis by imaging area, but there are different kinds of many different kinds of methods, and especially for the ultrasonic, I heard like 2D, 3D, 4D, those stories. 4D is like you're taking movies of some say your bodily parts that are in motion, like your heart or your other parts of body, maybe the fetus within the mommy, they could be imaged in 4D fashion, and it gives you a very clear view of for the diagnosis. Molecular diagnosis, on the other hand, has been a latecomer, but it gives you very say decisive answers. They're also very, very sensitive in some areas, and it's been a very powerful tool for the doctors and the patients, and especially some of these genetic biomarkers that I'm going to mention in a moment has very strong relationship with the therapeutics, how to treat or how to cure these patients. So those areas are also very much emerging. But basically, PCR, you should have heard how it works. and also it's used for some very specific the diagnostics area. And NGS, now it's next generation anymore, it's current generation sequencing, but still people call that NGS. By using those technologies, you can look into your whole genome or exomes or some very specific targeted area in order to find out the reason, the reason of the diseases or some cure at the same time. Many of you may know, may be interested in the AI and have some experiences in there, but if you, so the upper right hand part in here, I got it from the AI community. So AI, what AI is trying to do is, in many cases, it makes some decisions. Actually, so some guy is positive, like disease person, like a patient, but some other people are the healthy patient. But by using some type of AI, we are trying to classify them into a patient or the healthy people by just using some, information or parameters. There are generally true positives or true negatives. So they are correct answers, but there are wrong answers as well. So we use the word sensitivity and specificity, as well as negative predictive value or positive predictive value, or precision in this case, are being used to measure how good this AI is. And the total accuracy is like correct answers, some of correct answers divided by the total number of samples used in here. The same idea is being used for diagnostic methods. So among those, say, unknown population, we classify them into two different groups based on the gold standard method to tell you which one is patients and which one is healthy. Or you can actually find them out later after the death of the patient or the healthy people by looking at their anatomical structure or the very close examination. But using diagnostics tools, we want to do something similar to AI. We want to know if that person is sick or not by looking at some other parameters. Easiest one was like looking at their face or measuring temperature or weighing their weights or asking questions or doing some genetic tests or taking images. We make decisions, and then we want to quickly respond to that diagnostic results. One example I'd like to give you is about blood test. In order to make good diagnostics, we need biomarkers. So it's an indicator of some disease condition. It can be molecular, like DNA sequences or proteins or their concentrations and change of their concentrations, whatever. Those are some indicators of the disease state. Then those we want to find them from blood test, and there are huge needs related to it. In some specific areas of say biopsy, this blood or urine or cerebral, the CSF, the cerebral spinal fluid or bronchial wash, or many of these liquid tissue-like liquids were used for to replace or to supplement biopsy that does the molecular diagnostic procedures. And there's a company that was called Theranos, which turned out to be the largest fraud in the 21st century. That she developed. I mean, she made a company after getting out of Stanford. She made a small box like this, Edison machine, and she claimed that it can do more than 260 diagnostics by using a single drop of blood. That sounded pretty good. So she was super famous and super rich in a very short amount of time. Got invested like $0.9 billion investment, valued to $9 billion. But they closed in 2018, and all those legal suits are being carried out these days. She's completely broke now. But But when she said that these blood test machine that can do more than 260 tests in very short time, everybody was crazy. And all the money was coming in, and many of the diagnostic companies are very, very, anxious to talk with her and get in touch with their machine and everything. There were a huge voice of customers. Okay, in diagnostics field, molecular diagnostics rules. Genetic analysis, NGS or qPCR or whatever they might be called, genetic analysis was very, very necessary for them. Liquid biopsy, using liquid samples, was very, very something people wanted to get. It also included infectious diseases as well as genetic diseases. And people wanted automation and very easy access. Because the machine was only about this large, people are very, happy to place them into many single small, local hospitals or even in a pharmacy. And they wanted to get the blood tests very easily all the time. So people have found a huge demand and the needs, and they confirmed it, but the technology was fraud and she was not able to deliver it. So that was something people have learned in here, but we have to be cautious about those, finding the right people who are supplying the right technology and products. By looking at the therapeutics, the easiest way is looking at the, I thought was looking at the drugs that are being sold and making the largest revenues. And I wanted to look one by one from year 2016. There are drug names. These are the names used in the US only. In some other parts of the world, different names are used for the same drugs. Humira, Harvoni, Enbrel, all these drugs are the name of drugs. It's the marketing name. So it doesn't really tell you what it's made of and how it's being taken, like in vitro, injection or, tablets you can eat. You don't really know. But if you look at some of these, Humira is a drug used for the rheumatism. It's not infection, but it's got its own commercial pages, and it's being used by many people. And during the first maybe 10 or maybe less than that years, these blockbusters can generate huge revenue, and people are very much interested. Harvoni, Enbrel, many of these are anti-cancer drugs, and some are also the autoimmune disease drugs. Avastin, Herceptin, they're all the antibody drugs that are fighting against the specific types of cancer. In 2017, if you look at this, Humira is still number one. Harvoni has, got out of the list somehow, and those some of the anti-cancer drugs are still there. In 2019, Humira is still number one. Eliquis emerged from the lower section to the to up, and Keytruda suddenly emerged. Keytruda is a very interesting drug. It's anti-cancer drug, but it helps. It plays with your immune system to fight against those cancers that are they're invading the cancer, the immune cells that are trying to kill the cancer cells. So those drugs have emerged again, and then other cancer drugs or the immune disease drugs are up here. So if you try to come up with how people are dying, they're very close to what drugs are on the top list of these, in here. So if you're interested in therapeutics or helping people who are sick, there are clear two regions where many people are interested and people are, eager to spend their money. That's cancer, as well as this autoimmune disease. They are very hard to beat and also very profitable. And it's mostly working for, what I'm trying to say is that these are drugs that rich people, older generation people, really eager to pay their money. And it's actually, many of us are going to be live very long, and we are going to need many of these drugs in the end. So that's why people are interested in helping keeping the health condition of older generation people. So that is also being told in these pharma drugs. In many of these drugs are monoclonal antibodies, and before these antibodies were used for, for some specific the therapeutics, people have been working with small molecules that can dissolve in the water very well, so that it can penetrate into many small, parts of our bodies inside of their, cells easily. But because of many side effects, people have been trying to find very specific drugs, and it ended up searching drugs that are being made of biological methods, not chemical methods. So these drugs have emerged over time. Now it's taking very high list of the blockbuster drugs lists. And when we look at the largest pharmaceutical companies, North America and Europe are leading the group, and many of these companies didn't exist when I was at your age. Like say Moderna, it never existed. Virtually they didn't exist about 2 years ago, I'd say. But now it's a huge company because of Corona-19. Johnson & Johnson has been the #1 over many years. Pfizer, as you know, AbbVie, they came up with monoclonal antibody drugs, and now they're one of the biggest. Amgen is also the same. Merck was the strongest guy in the small molecule drugs. Now they're doing all different kinds of drugs, but because of the newly emerging, drug companies, relatively new companies, they don't, they don't lose against these very old pharmaceutical drugs in size. And that's the power of the blockbuster drugs, I would say. This is many of you know that this is the pharmacy, pharmacy chain in the U.S. They also take part in this the drug industry, and they're getting growing day by day. Roche, Novartis, many AstraZeneca, Sanofi, they are big. BioNTech, due to COVID-19, they've emerged from almost nothing, but the impact of a blockbuster drug or vaccine helps this company just as large as this, like more than 100-year-old companies. They are, comparable in their the revenues nowadays. If you look at the Asia, very happily we can find Celltrion here, the Korean company. I didn't really expect that any Korean company would emerge this early when I was at your age, but but I'm very happy that I can share this slide with you. But there are other Asian companies in here, but the biggest ones are in Europe and North America, and that is mainly due to the power of distribution and also the maintenance or the development that has been practiced and strengthened in the Europe and the North America mainly. So Asia has been a slow starter and also got smaller the market size so far, but I expect that will be changing in the near future as well. Anyway, those are some very raw views on the diagnostics and therapeutics, two different areas of biotech, biomedical engineering, and I would like to finish by telling you that we need to find the needs and the approach and benefits and competitors very explicitly written out so that we can decide what to do and how to approach it. Thank you very much. It's about the presentation for you, and I'd like to answer any questions if you have any. Thank you very much.
Thank you, Dr. Lee. Do you guys have any questions? You can leave on the chat board, or you can turn on your microphone and ask to Dr. Lee directly. it was quite uh, helpful talk, I think, for the freshmen. I think so, not only for the topic itself, to look at the market and to find the applications about it. I think that will be when these guys studying the major class topics in a BME or the general things in during their undergraduate. I think that will be actually really important when they go out to the real society and the research community. I have one questions about the market. So you mentioned about the big markets. For example, the cancers or the autoimmune diseases are quite big ones. But however, the Moderna cases you also mentioned, they develop their techniques a lot, but when they develop their technologies, so now they actually has a huge fruits for that. But
Yep.
for a long time, they actually look at the develop their technologies without the proper markets, they can make a profit. So as a result, I think they did really good approaches, but about 3 years ago, I think that would be quite stupid approaches. How can we distinguish those kind of two different extreme cases, which can make totally different outcomes after in the futures?
Yeah, well, that's a very good question. And it was one of the questions when I was working in Samsung early 2000, because my bosses, they wanted us to find something very big and very, say, productive area of business. But I mean, when I talked with Dr. Guan, probably it was late last year or early this year, by asking how the mRNA vaccines really work. How can they really deliver it? I don't really believe in their technology. I still remember we had that short discussion, but
Yeah.
it was, I mean, up until last year, everybody in the world, maybe less than 100 people will disagree with that. Everybody in the world thought that mRNA vaccine is a hoax. It never works. And the technology related to it is not worthwhile to mention. Now, people have realized that it's a very wrong idea. And within this here, we have a lot of lessons. And many of these lessons were actually practiced by large pharmaceutical companies already. Many of us, or in the academia, didn't realize the value of some technology that were hidden. And it is very true that many drugs are being focused on, many development efforts for the drugs or the diagnostics is focused on cancer or autoimmune diseases that are very lucrative market and also very huge needs. And it'll help people quite a bit. But when suddenly something like this, like incidents like COVID-19 happens, we were not really ready. We thought that it'll happen sometime, but we didn't really hope. We hope that it'll not happen within our lifespan. And many companies like Pfizer, they invested in BioNTech very early. But BioNTech was not a specific company that Pfizer invented, but Pfizer invented throughout, hundreds of different small companies. And they were, say, growing them. So in other sense, people can think that Pfizer never does any very early stage drug development anymore. They want everybody else, like students or professors or small venture companies would do those type of research and gives the seed money so that they can grow in a big farm, and they want to pick them when they bloom, and then cost a lot less than spending huge amount of money into their internal research. Many of the other companies are doing the same, but this time Pfizer and Moderna, they were successful. So it gives us another lesson that, okay, whatever technology or some area that might be promising, I think, will be able to get investments and get proper way of growth by focusing on the topic. And that's how really actually the 21st century business development is being carried out. Many outsourcing and many venture companies, very active interactions among them. And that's the, say, maybe the cheapest and most efficient way of coming up with many of these diagnostics and therapeutics results. Too long answer for a long and short question.
Okay. Also, so I have another questions about your company, because you didn't mention anything about your companies during the presentations. Could you introduce what you're doing in the lab spinner shortly?
Okay. Lab spinner it started about 3 years ago as with a business model of developing a diagnostics especially for the cancer using blood or urine. It's a liquid biopsy diagnostics company. It started as that. Now, as I'm joining as a CTO and a CEO in a moment, we are trying to transform our company into a pharmaceutical company. We are coming up with some collaborators who have good technologies to grow some cells, and those cells are generating exosomes that contain pharmaceutical molecules or antibodies, and those cells are also very good, have got very good quality of manipulating the genes so that they can produce some antibody-like peptides that can be presented on the surface of the exosomes or as the cargo of the exosomes. And these exosomes are natural, so they're pretty stable and can be delivered very easily throughout our bodies. So we are working on to evolve our company into a pharmaceutical company, and hopefully we hope to grow as one of those Asian pharmaceutical companies in the coming years. Large one,
big circles on that corners.